So what do you want to learn next? While at this flow, I'll also look at so I've also added one more slide, and it's in the note pack. Of the examples in life cycle costing, okay? So these are broader examples that you can use as well as very focused examples. So the life cycle costing, at the beginning of it, people were starting to say it's 1-5-200 rule. 1 is the construction cost, initial cost. 5 is the operational cost. And 200 is the value of it. So if you look at a mall, like a shopping mall, 1 might be the construction cost, might be 5 million or 10 million or crores even. 5 will be the operational cost, the repair, the maintenance and everything over 50 years span. But 200 is the value for the people in the mall. So what does that shopping mall make the entire area? Does it increase the value of the area? Highly likely. If you want to know, without quoting some examples, if you say an area where there's going to be a metro station, you know the price is going to just go up. Okay. Similar to that. So the value is calculated from a user perspective. Okay. So quite often value should be used in justifying a lot of things. Okay. So there are some examples of that. You have access to the slides anyway. So hospitals are something where this value and the operational cost is significantly high, because hospitals by their true nature, they change very, very fast. The operation theatre today is not the operation theatre tomorrow. Technology changes, the requirement changes, the size changes, everything changes. So if you're designing a hospital for 75 years, really be careful, because they're in the business of changing. So you need to be looking at how can we adapt that environment as fast as we can. Anyway, so I'll leave that slides to you. It's not important to go through it, but there's some quick codes on how to use life cycle costing. This is ideal for those who are in teaching business, and some explanation of how the discount factor. You know the discount factor that I mentioned, that I'll borrow 1 lakh from you and then give it back in 10 years. How the discount factors will devalue the money. The higher the discount factor, larger the devaluing of money. The discount factor is influenced by interest rate, but more by inflation. So if you look at PFI or DBFO, what is the one here? The Public-Private Finance Initiatives. BOT, sorry. That kind of systems, there will be some calculations at the back end using a discount factor. In the UK, the Treasury has defined the discount factor to be 3.5, I think. So for all PFI, it's called Private Finance Initiative for us, it's have a discount factor to calculate. 3.5, yeah. Inflation is low for us. Developing economies will normally have a higher inflation rate. Yeah. Your cost increase is scary. So, anyway, what I used to get for 100 rupees in Kerala 5 years ago, I will need to pay nearly 300. Kerala is a unique example of people's salary just shooting up. Labor cost is extremely high. So, I started earlier by saying you need to look at how we can sell the holistic approach to the clients. One tool was life cycle costing. The other tool is environmental impact. Okay? Every repair has an environmental impact. Whether that's impact is on users. So if you look at a stretch of road and you're repairing the road years after years, you are destroying the driving experience of the users. You are costing them a fortune by having to queue and wait and delay. You're destroying the environment of the people around it. So if you have a shopping mall and you're repairing the road before the shopping mall, I don't think they're going to be happy, because they're going to lose the customers. Nobody would want to go in the midst of all of that to park there to buy a shopping experience. Okay? So all of these actions have an environmental impact. The other environmental impact is the chemicals and the materials that you use. Okay? Environmental impact for chemicals are something that we understand quite well. If you look at Bhopal or any of the disasters that happened around us, we know the impact of that. But we should also be aware of the environmental impact of concrete. If it is the second largest used man-made material, it definitely have an impact. Okay? So you need to be able to quantify it. We can quantify it. Everybody can. So that environmental impact will impact an individual or a nation in different ways. One of the best environmental impact that we all are familiar with is called the global warming potential, GWP. Okay? It's to do with the CO2 emissions and then the natural heating of the environment or natural extreme environments. The other one is human health. Like that, there are different factors in which you can express your environmental impact. Okay? So the wording environmental impact here refers to quantifying everything holistically to express that with respect to the cancerogenics or human health or global warming potential or resource efficiency, all of that. Okay? This is a business where you will have to buy a software, because the data bank or the database of every product has been quantified by these softwares. Okay? You can do it yourself, but it's an extremely messy business. And you will need to constantly update it. So there's so many softwares available. For those who are in the teaching or studying business, you can download the software's beta version for free. It will be limited on where you can use it, but you can still learn with it. I'll introduce some softwares as we go. So life cycle assessment looks at all the aspects of a product or a project. Similar to life cycle costing, it should be done from cradle to either gate or site or cradle to cradle. That boundary should be defined. So if I say extraction, manufacturing, distribution, and I draw a rectangle here, that is cradle to gate. Okay? If use and maintenance is brought in, then I'm looking at a service life to that. Okay? So I can only then quantify it the full circle, saying cradle to cradle, because in here it's end of cycle is brought in. Okay? So that rectangle that you need to draw is entirely up to you, but when you draw it, you will need to say I'm calculating everything for cradle to whatever. You will need to explain that in small prints. Okay. So I'm going to look at concrete production. So this is the softwares, by the way. CIMA Pro is one such software. I use CIMA Pro, but I haven't used CIMA Pro in a long enough time. My knowledge in that is rusty because I have a colleague who's focusing on that. She's a student of mine, but she's more environmentalist, so she's taken over completely. There's another one called Gabi. Okay. They're very similar, but I think Gabi is preferred by anybody in the manufacturing industry, steel industry and all that. CIMA Pro is more for construction related stuff. And the professional institution related one like Leeds or Briam, they all do the same task. If you are building things from the scratch, I would suggest start with the ISO codes. The ISO code that we refers to, 15686, also has a part on environmental impact or life cycle assessment. So you can learn from any of them. So these are the three things available. Cradle to site, so cradle to gate, cradle to site, and either cradle, sorry, there's one more thing then. Cradle to grave or cradle to cradle. Cradle to grave means you've used the purpose, that's demolished, it's on the ground, disposed. That's not something we really prefer because that means landfill. We don't even have space for humans, left alone landfill. So cradle to cradle is the other thing. Okay, so I'm going to look at, let me see. When you go down to analyze, and this is why I said it's a software that's very critical here. When you go down to analyze it, you will need to take one of the indicators. Okay, Eco Indicator is a European database. The Malaysians kickstarted the work long ago, so they have a very strong database. You might have a database of yourself, I'm not sure. But if you don't, you may be better to use a Malaysian database than the European database. Where it matters is that if your electricity is produced by nuclear power plants, your database and your indicators will have lower impact than if your electricity is produced by diesel burning. So for example, Sweden, of all the European countries, will have the lowest impact because they have the most clean energy than any of us in Europe. UK will reach there in no time because most of our source of energy now is wind power. Wind power has taken over as the large source of energy. Okay, we don't have nuclear. We do have a nuclear, but we don't know what to do with it. But so you will need to select one of the analysis. This is better done by somebody who's more trained with it and somebody who's more working in that area. So if you can afford to get someone to do that and train them up and let them be the person for an organization. Partially because things change in this world constantly and one person can keep up to date with it. And that's exactly what I did. I let my then student, now a colleague, who just took over the area. So in terms of the damage category, this is what I was saying. You can talk about the damage to human health, ecosystem, resources, global warming, all of those stuff. So it depends on what impacts you. Okay? If a project that has no other impact than on human health, i.e. mineral mining or whatever, then it'll have an impact on human health and resources. Human health for the people around it, resources because you're depleting the resource. So the goal is to quantify the impact of everything, every process. Scope is something you need to define. Again, this is where the cradle to gate system comes in. Okay. So if you say production, extraction of raw minerals is the only thing, then you're saying cradle to factory. If transportation of raw material, manufacturing process, everything is brought in, then it's cradle to site. So we're going to look at a case study where concrete production is looked at by a precast concrete producer, and they were looking to see which concrete was better for them. So they can define the function unit. They're saying per meter cube concrete. If it's a product, they might say per meter square. Okay. So we're going to look at, in concrete, the largest impacting people are aggregates and cement. Am I right? This is Northern Irish example, so water is not a major impact for it. It rains all the time. We have plenty of water. But so these are the two major impact, and assuming there's not much chemicals or anything used, which is fair enough for a normal concrete, but if you're using alkali activated stuff, then the alkalis and silicates need to come in. So in the so the next thing is to write out every process that may exist on that. Handling of materials in the plant, batch and manufacturing concrete, handling of materials from the batching plant, because everything that involves a crane or a lift or a rotor or a lorry, everything needs to be defined. And handling the finished product. So these are the things. And the software allows you to quantify all of that as individual functions. Okay. So concrete at the top, that's what I'm trying to get at. These are the feeders to make the concrete. Okay, so let's say cement, for example. Cement is produced and transported to the site. Site is at Ardbo. Okay, so the transportation has an impact. So we're gonna take the database from the cement manufacturer to get all the information we need, plus we add the transport of however long it's from the cement manufacturers to us. Okay. Cement production system is coming from the cement manufacturer database. Okay. So that makes you the cement. Each of that will have a related CO2 emission. Okay. Quite often when you look at the environmental impact for a material, what you're looking at is the life cycle inventory, basically the breakdown of everything related to the production of 1 kilogram of steel sleeper for railway. For 1 kilogram of steel sleeper, it emits barium sulfate, bauxite, iron sulfate, lead, blah blah blah, all of it. It emits a lot of these things. And then the outputs are acetic acid, calcium,